Hello, this is Mohanda Didia. This is module 11, related video number 3. In this particular module, we are looking at equipment and processes for suspension. We already looked at equipment and processes at labs. This third related video submodule focuses on process at commercial scale. Reader is requested to refer to module 7.2 of solution to get the details on conversion of weight and volume using densities. First step is for each component, we should specify weight and volume using the density. In some cases, we may not have actual density, so we can estimate it at the manufacturing stages. Calculate total volume and weight at each step. Determine the mixer range for each step using 40 to 70% capacity. Based on the mixer range, determine the type and size of mixers and containers are needed for each step. That will depend on what's available at the commercial manufacturing site, and processes will have to be adjusted to that. And that's why it's extremely important when we are developing the product in the lab, we understand what the mixer sizes are, the manufacturing capabilities are, so you develop product. Include a rinse step for each active that's transferred. This will minimize the loss of active. Let's look at the batch formula. This batch formula is for paracetamol, active ingredient used in Tylenol and generic drugs. It has D90 of less than 50 micron. That means particles are fine, less than 50 micron in size. Has several phases. Part A is carbopol polymer dispersion phase. This is desuspending agent, and it is dispersed in water. EDTA and saccharin are added at this stage. Part B is a sugar phase. Sucrose and sorbitol are dissolved in water. Methyl and propylparaben, which are preservatives. Solution of sodium hydroxide is used to neutralize carbopol. Part D is the drug phase. Drug is insoluble and it's wetted using polysorbate 80 in water. A rinse step is provided. Flavor and colors are added. Purified water is used to QS the batch. Let's look at percent weight to volume. This is how most of the formulas are written. For example, 0.3% weight to volume means 3 kilos of carbomer in 1,000 liter of the product. Similarly, we can look at it. Sucrose is 40% weight to volume. That means 400 kilos in 1,000 liter. And we'll take one more example. For example, polysorbate 80 has 0.5% weight to volume. That means 5 kilos in 1,000 kilos. So once we have all the amounts into kilos, we can add total weight for each step. Shown here, 125 kilos for part A, 977.2 kilos for part B, 0.2 kilos for part C, and 129 kilos for part D. Part E added so they are not separately mixed in any container. Next, to calculate the volume. Obviously, 120 kilos of water having density of 1 will be 120 liters. And how to calculate volume from estimated density or actual density was discussed in module 7.2 and is not repeated in this particular module. So again, reader is requested to go to module 7.2 and understand how these are calculated. Part A is 125 kilos and the volume is 124.9. We can estimate mixer capacity and optimize that. Sugar phase is 977 kilos. It has denser materials such as sorbitol and sucrose, and its volume is 687.3 liters. Part D is 129 kilos. Its volume is calculated at 123.8 liters. These are estimated volume. We can determine the type of mixers that would allow appropriate mixing based on 40 to 70% capacity. For example, the total volume is 1000 liter and main tank is used for final product as well as the sugar phase. Determine mixer size. 1500 liter mixer will be reasonable and both phases will be within 40 to 70% of the capacity. Let's look at some of the processing equipment that are used in manufacturing of this type of products. In-tank homogenizer, commonly used in these type of suspensions. And one can see that homogenizer of this type will be able to suspend the particle and dissolve it properly. It is lowered appropriately. Let's look at the filtration. The fluid comes in and cartridge filter will remove the solids. The filtration has to be carefully used. Again, once we have a final suspended particles of active, we generally try not to use filtration unless we have a specific purpose such as sterilization. Let's look at the mixer, propeller mixer and a homogenizer in the tank. So propeller mixer is commonly used and that's sufficient for dissolving the sugar phases. Let's look at and have that here so that you can understand how noisy these equipment are. And mixing will continue and you can see that homogenized. So let's look at part A. Part A is a polymer dispersion phase. The formula is shown here in kilos. We can use 200 liter mixing tank with high shear mixer. Propeller mixer should not be used as many of these polymers will form lumps and then it's difficult to separate the lumps. First step is add water, dissolve sodium EDTA and saccharin. Those are both soluble materials. And then Carbopol 971, also called Carbomer, is slowly shifted through 150 micron to break lumps in rapidly agitating liquid at 800 to 1500 RPM. Just as Carbomer is added because it will start increasing the viscosity. Once all the dry polymer is introduced, reduce the agitation speed to 400 to 600 RPM and position mixer to minimize air entrapment. Continue agitation for 60 minutes. In-process check would be visual to verify the phase is lump-free. This has been shown in previous videos. In this case, check weight of 125 plus or minus half a kilo. Hybrid mix for up to 12 hours. Second phase is solution phase. Formula is shown here, contains parabens, sucrose, and sorbitol. This will be done in main mixing tank. The volume of this phase is suitable for 1500 liter tank. 1500 liter capacity with dispersing type dual mixers, homogenizer as well as a propeller mixer to heat water to 95 degrees, dissolve metal and propylparaben. Add sucrose through a powder shifter and cool it to 75 degrees. Mix at low RPM. Filter the sugar solution through filter press and recycle it back into the main tank, cool the solution to room temperature, and add the sorbitol. Transfer carbomer dispersion into the mixing tank at a low RPM. Part C is sodium hydroxide addition for neutralization to a small container and funnel neutralized to a pH 4.9 to 5.1, mixing speed that it avoids air entrapment. So in process test, check the pH. Insoluble drug is prepared separately in 200-liter tank. Polysorbate 80 is dissolved in water, and then active is added. It is homogenized with high-shear homogenizer, and again, it can be wetted if required for 12 hours. Check the weight control. Weight check is 129 kilos. Rinse water. 20 kilos is added to the main upon completion of a transfer. Active drug. In the main tank, color and flavors are added, and water is provided for QSing. The suspension then is continuously mixed in storage vessels until packaging is completed. In-process sampling of a bulk product is taken from top, middle, and bottom from the storage tank prior to packaging. pH, viscosity, density assay of active as well as preservatives, and microbial testing to show that the bulk is within the specification. Packaging, suspension product is continuously mixed so that maintain the uniformity. Bottles are and then filled. Samples are taken at 10 different time intervals from initial to final, representing the run. That's a common practice. Test samples are provided to quality control for testing according to the product specification. Packaging. Bottles are washed with air, and air is blown to clean the bottle. And then they are filled here, and you'll see the filling heads come down. The bottles that are filled move on to the conveyor belt for capping and labeling operation. It's important to monitor packaging and show that the suspension is uniform throughout the process.